going to exponential, the exponent number, or we call it exponential expression. So any language we call it something. Exponent number or exponential expression. So we have to look at all this, and now let's take them one after the other and deal with it. Are you ready? Let's begin. Good. Now the question is, what is exponents? I told you we know it before. Let me show you. We will see that you know it before. Let's say you have number that is raised to some power. This number here is called the base, and this is called the exponent. Some people call it index. Some people call it power. Okay, so I can say x to the power of n, or I say x into the index of n, or sorry, a to the power of n, or a to the index of n, or I say a exponent n. You see, it's what you do for. Now, we have some laws. Some people call it laws of indices. Law of indices, or law of exponents, or rules of power. Okay? Now, the first one, the first rule is called productive. We call it productive. What is productive? Let's say you say a to the power of m times a to the power of n. M is the power, n is the power, a is the base. Since the base is common, you take one base, multiplication becomes addition in power, and then we have the first rule. Of course, there's a proof of all this, but I don't want to bother you too much on that. It's common. If it's not common, you cannot take it. It must be common. Let's say, for example, let's say 2 to the power of 3 times 2 to the power of 2. Okay? What the law says, 2 is common. Take 1, 2, and then add the power. That is 2 to the power of 5. 2 to the power of 1 is 2 in 5 places. Let me write it. It means 2 times 2 times 2 times 2 times 2. Don't say 2 times 5. It is wrong. So this is 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. So the result of this line is 32. Let's do one more. Let's say now we have 2m to the power of 7 times m to the power of minus 3. You say this guy needs to start again. Be careful. Is common. Pick one m. What the law says, add the power. So we have 7 plus minus 3. Which is what? M plus minus is what? Minus. So 7 minus 3 is what? 4. And this is it. I hope we are together. Let's go to the second rule. The second rule is called quotient. Quotient rule. Quotient means division. Yes, it's division. So I can say, the law says a to the power of m divided by a to the power of n. The same rule will appear. But now, don't forget, multiplication becomes addition. For this place, division becomes subtraction. Minus. So I can say a is common. M minus n. This is the first one. This is the second one. Let's have an example on this one. Example. 3 to the power of 7 divided by 3 to the power of 5. 3 is common. Pick one. 3, 7, 5. That is 3 power of 2, which is 3 times 3, which is 9. First, let's see, right? Second, let's do another example. Two examples. Let's say we have 2y to the power of 9 divided by 2y to the power of 8. 2y is common. So I can pick 2y, and I have 9 minus 8. 9 minus 8 is what? 2 to the power of 1. This means 2y, right? Power of 1. That's what I mean. The third rule is called power of power. Power in a power. Very good example. Before that, let me write power of a power. That is, we have a to the power of m times n. You see, this is 2 power. You can have 3 power. You can have power of power of power. What is the law says? The law says if it's power of power, multiply them together. So we have a m times n, which is a m n. Power of power. Example. 4 to the power of 3, power of 2. Let me do this one. Let me do 2. And I can use it more. So simplify this then. What do we have? 2, 3 times 2. Power of power. You multiply the power, right? It is 2. 3 times 2 is what? 6. This means 2 in 6 places. When 2 in 5 places is 32. 2 in 6 places is what? We add one more, right? That is what? 64. If you like, you can write it. 2 times 2 times 2 times 2 times 2 times 2. 2 in 6 places. Okay. Let's do another example. Let's do this one. We have minus 3 to the power of 2 to the power of 1. Okay? Power times power. I mean, power is addition, right? So I mean multiplication. So we have minus 3, 2 times 1. That is minus 3 times 1 is what? 2. Minus 3 in 2 places. That is minus 3 times minus 3. Minus is plus. 3 times 3 is 9. That is what? Are we together? Let's move to the fourth rule. Power of a product. That is, let's say we have a, b to the power of m. A, b to the power of m. Look at the parentheses. Parentheses means everybody or every number or every letter inside the bracket share this m. So we can write this as what? A to the power of m times b to the power of m. They share it. This is very important. A good example. 2 to the 2x to the power of 3. For example, it says what? These 2 share this 3. This x also share from this 3. So we have 2 to the power of 3 times x to the power of 3. And 2 to the power of 3 is what? 8. 8. And x, this is letter. There's something you can do. And this is a good example of alpha numeric number. That's why the topic is, the big topic is called. Let's have another example. Under this, minus of 6p to the power of 2. Be careful here. This minus share from these two. This 6 share from these two. This 9 p also share from these two. So I can write this guy as minus squared 6 squared p squared. Minus squared means minus times minus, which is what? Plus. So this is plus. It's gone. 6 squared is what? 6 times 6, which is what? 36. And p squared. This is it. I hope you are following. These are the rules. These rules are very important. You may think that it's so easy now, but in the future you're going to make use of all these rules. Yes. The next rule is power of quotient. Power of quotient. This is rule 4. Let's call this one rule 5. Power of a quotient. Quotient. That is, this is multiplied. So you can say A divided by B, everything M. That is, A share this M, B also share this M. And a good example, quickly, we have 3 over 4 to the power of 2. Which means that 3 to the power of 2 divided by 4 to the power of 2. This is 3 in 2 places, 9. 4 in 2 places, 16. Finish. Finish. Let's move on. You know, we are doing two examples. Let's just do another one. Let's say we have this amount. Let's say we have 2w divided by 3 to the power of 3. I have put this rule inside this place. So I have put this there. I deliberately there. To know that there is connectivity there. So this guy is seen as 2 to the power of 3, w power of 3, 3 power of 3. All of them will share because they are in brackets. Everybody in that bracket share that power. So 2 to the power of 3 is what? W. What will be here? 3 to the power of 3 is what? 27. And this is. If you like, if you don't want to write this way, you can write 8 over 27 WQ. It's the same thing. You see, you put the numeric letter, letter, and you put alphabet. The sixth rule is zero exponent, or we call it zero rule. Zero rule is a very funny rule. The zero rule says anything to the power of 0 is 1. You know, why can't you call this one the first rule? It's the most easier one. Yes, I know. I just deliberately delay to this time. So anything to the power of 0 is 1. But be careful. 0 to the power of 0 is not 1. When we do calculus, we're going to solve it out. But for now, anything to the power of 0 is 1. Okay, example. 3 to the power of 0 is 1. Example 2. 3 times 7 divided by 8. Everything power of 0. Since everything has power of 0, don't go downstairs to calculate anything inside because it is equal to 1. And some of you are busy. Yeah, you have to follow the board mass. Board mass, you have to work with this side first. No problem, work with them. 3 times 7, 21. 21 divided by what? 8. So 21 by 8, everything power of where? 0 is 1. Is 1. Seventh rule. Now we are on negative exponent. negative. That is, the exponent is having negative number. So if you have, let's say, the rule says a of minus m. This minus, it becomes 1 divided by the remaining number. Minus becomes 1 divided by remaining number. There is a proof for this. There is a proof. Now, example. 2 to the power of minus 2, that is 1 over 2 to the power of 2, which means 1 over 4. Another example, let's say we have 3t to the power of minus 3. Now I've put two rules here now. The first rule, power. So this 3 share from here, this t also share from this. So if you like, you can write it as 1 over 3t, everything power of 3. Which means 1 over 3 to the power of 3 times t to the power of 3. They share it. Now, you can say this is what? 1 over 3 to the power of 3 is what? 27. 27t cubed. And this is it. If you don't like this method, you can use this one. Share it immediately. 3t minus 3 is what? 3 minus 3 times t minus 3. Right? You can share it immediately. And now follow the rule now. This is 1 over 3 power of 3 times 1 over t power of 3. Power of 3, 3, 27. I have 1 over 27 times 1 over t, 2. Now multiply. 1 times 1, 1, 27 times this, 27 t. It's longer, right? Choice is 6. Choice is 6. Let's move to the 8th rule. The 8th rule is called fractional. I believe you know what we call fractional number already. Now we have to look at fractional exponent. Exponent. Fractional exponent means the base is carrying fraction number. The base is carrying fraction number. Now, if the base is carrying fraction number, there's a rule here. Base, you build house for it. The denominator, you put it down. And numerator, you put it up. It's called fraction. Okay? It's a rule. Denominator, come here, power comes here. If you don't want to write power like this, of course, you can write like this. I'm sorry. Insert. Insert. Listen. $27, 3, 2 over 3. 27 to the power of 2 over 3. 27, build house for it. 3, square. Everything is square. Right? And what does it mean? This means that which number we are going to multiply 3 times. That will give us 27. The number to multiply 3 times that will give us 27. If you like, you can use our normal division. 7, 3 can go. 9, 3 can go. 3. So we multiply 3 times. That will give us 27. So instead of writing this now, I can write it as 3 everything squared. That is, it's 3. I can multiply 3 times. That will give me the save some space here. And this is what? Let's do another. Let's say we have 25 to the power of 0.5. minus. So how this one comes? Don't problem. Don't bother yourself. Don't commit suicide. It's very easy. It's very easy. What you have to do is to follow the rules. What is the rule? Negative becomes 1. Do that one first. 1 over 25 to the power of 0.5. 0.5, convert it to fraction. 0.5 is 5 over 10, which is 1 over 2. Right? So I can write this guy as 1 over 25, 1 over 2. Right? Now, this one is like this one. I can build out 1 over the roots of 25 to everything 1. So that one, this one. So if you like, you can move it to this way. That is 1 over which number to multiply 2 times? That will give us 25. Obviously, it's 5, right? And any power of 1 is what? That number. It is a good. The good news is that all these 8 rules that we have applied to real numbers, whole numbers, fractional numbers, decimal numbers, we can also apply it to irrational numbers. That is, if you have a as our base, the root here is irrational. This is same with base, and this is called irrational exponent. Irrational exponent. So the same thing you can apply to all the 8 rules. Let me just do one for you. You say a to the power of root 2 divided by a to the power of root 2. This is what? A is common. So we have a to the power of root 2. Okay, let me make it more serious. 2 root 2. Division become minus root 2. So this is 2 root 2 minus 1 root 2. So 2 minus 1 is what? 1. So root 2 is common, we pick 1. Remember where we deal with irrational number. So the same thing you can apply it to all these rules. I can also apply it to, let's say, 2 to the power of root 3 negative. So apply it. What the law says, the minus becomes 1. So we have 2 to the power of root 3. And then it's finished. We stop it. There's no need of. Okay? So this is just safe. So instead of using normal numbers, I can just use irrational numbers. Now let's see the application of exponential. And this is very important. Many students used to have problems, especially when they are pressing their calculator and they are getting their answer in scientific form. How do you convert it to normal, to standard, and back to scientific? It's very important. Let's say we have a very big number. For example, we want to write 1 million. 1 million. 1 million has 6 zeros. This is like 1 million, right? Now it's long. You can make it shorter by writing 1 times the standard one. The standard number is 10. You know, we can't decimal. When you go to decimal is 10. When you go to decimal, you stop and start writing again. So this is 10 to the power of how many zeros? 1, 2, 3, 4, 5, 6. 6 zeros. So instead of us to write a very long number, you write this in scientific form. This is called in scientific notation. What of 1 trillion? Or let's say billion. 1 billion means 9 zeros, right? So instead of writing 1 0 0 0 0 0 0 0, it's long. So we can just say it's what? 1 times 10 to the power of 9 in scientific notation. Trillion. Trillion has 12 zeros. Trillion, let's say we have 4 trillion. 4 trillion. This means trillion has 12 zeros. Billions has 9, trillion has 12. So this is 4. So this is what? 4 times 10 to the power of 12. So we take the number and number of 0. This is in scientific. We also have what's called 100. 100 is called googly. 1 go is decimal. 100. It means 100 zeros. So this is 1 times, let's say 9. 9 googly, that is 9 times 10 to the power of 100. So you see, this scientific make life easy for us. Instead of we have to be writing 100 zeros. You might want to write 100 zeros. This board will be full. So that's how we use scientific. Now let's also solve. What if number it is not increasing, number is reducing? We call this one decimal. Let's say we have something like 0.000000345, for example. This is decimal, right? It is long. Computer will not, your calculator will not give you something like this. You will write it in standard form for you. So what do you write? This is where the number starts. So we have 3.45 times how many zeros before that number? 1, 2, 3, 4, 5, 6, 7, 8. That is 10 to the power of minus, because the zero comes before the number. Minus 8. This is called the standard form, and this scientific. Let's also have another example. Let's say we have 0.000401. Be careful. Once the number starts, even if there is 0 after, it's not your business. Be careful. So this is what? 4.01 times 10. How many zeros do we have? 1, 2, 3, 4. Before numbers. You don't count this one. I deliberately give it this example. You don't count this 0. 0 is within number. Is a number. But number 0 before number is 1. It is 1, 2, 3, 4. So it's negative of 4. This is what? Now let us see how to put this together and get some results. Ready? Let's solve this example. Compute and write the answer in scientific form. So we'll solve it and we'll write our answer in scientific form. So let's start. This guy is multiplying this guy multiplying that. First, don't say you want to open this one 0 on a lot of zeros. So what I'm going to do is, don't forget the law of indices. This is whole number. This is whole number. This is fractional. Exponential number. Exponential number. Put them together. That is 6.4 times 1.5 divided by 3.2. These are the whole numbers. Now the other numbers: 10 to the power of 3 times 10 to the power of minus 5 divided by 10 to the power of minus 8. It's the same thing because they are all multiplication. If addition is there, you cannot try this. So this place you have to follow the rules, convert all of them from decimal to fraction, or you must use calculator to multiply it. So choice is it, but I would like to use to convert it in case I don't have. So this is 64 out of 10 times 15 out of 10 divided by 32 out of 10 times 10 is here, 10 is here, 10 is here, 10 is common. I can pick one 10 according to the rule. So I can say 10 to the power of 3. Multiplication becomes addition, the product rule. Plus, minus 5. This is what? Division. And division becomes negative quotient rule. You see the application? Minus minus 8. Minus that come from A and the original minus from A. So for this one, quickly, I can cut it without wasting time. This guy, I can write it as 64 over 10 times 15 over 10 times 10 over 32. You agree? Division become multiplication and you find the reciprocal of it. Times this one now become 3 minus 5 plus 8. Right? Now let me take my scissors and try to cut it. This 10 cancel this 10. This 10 is no. 32 here 1, 32 here 2. Good. 5 goes here 3. 5 goes here 2. 2 cancel this 2. Wow! We have cut. This is 1 here, this is 1 here. So everything is almost gone. You see, that calculator, you can solve it. What is left? This is gone. 3. This is 1. This is 1, 1, 1. So we have 3 times 10. What is this? Board maps. 3 plus 5. I mean 3 plus 8. 11. 11 minus 5. 6. And this is 6. In standard. Sorry, in scientific form. If they tell you to write in standard form, that will be 6 zeros, right? That is 3 million. But you see, it's too long, so it's good to put the answer in scientific form. And that is the end.